Good morning, children. Welcome back to ICAN Physics. Now in this class, we are going to study about 1.10. Okay. A point charge of plus 10 microcoulomb. Okay. A point charge of plus 10 microcoulomb is placed at A. Okay. At a distance of 20 centimeter. At a distance of 20 centimeter. Another identical point charge of 10 microcoulomb. So another identical point charge of 10 microcoulomb. So it may be B. Okay. Now the identical point charge of -2 microcoulomb is moved from a point A to B as shown in figure. Okay. So now what they are giving, it may be A or it may be C. So for that I want to give the name C and D. So from C to D it is moving. Okay. Calculate the change in potential energy. Calculate the change in potential energy. Okay. So what is the expression for potential energy? Epsilon equal to 1 by 4 pi epsilon 0 Q1 Q2 by R. So this is the general expression for electrostatic potential energy. Right? Okay. Now to assemble these two charges, A and C. Okay. So epsilon A and C, that is equal to 1 by 4 pi epsilon 0. Okay. Now the charge is taken as QA and this one can be taken as QC and this one is taken as QB. Okay, so now it becomes QA QC. Okay, so QA QC by RAC. Okay, now do you get it now? Do you have any doubts? No doubts. Okay, now I am going to find electrostatic potential energy between B and C. Okay, so B and C, that is 1 by 4 pi epsilon 0 QB QC by RBC. Okay, now between A and B. Okay, so between A and B. So 1 by 4 pi epsilon 0 QA QB by RAB. Okay, so what about the total potential energy? So for total potential energy, I want to add all those things. Okay, so epsilon A to C plus epsilon B to C plus epsilon A to B, that is equal to, in all the three terms, 1 by 4 pi epsilon 0 is the common. So 1 by 4 pi epsilon 0 can be taken as common. So what about the remaining? QA QC by RAC plus second one. So QB QC by RBC. And the third one, QA QB by RAB. Okay, so this is the initial electrostatic potential energy. So I want to give the name initial electrostatic potential energy. Okay, so now we are going to substitute the value. So initial electrostatic potential energy equal to 1 by 4 pi epsilon 0, that is 9 into 10 to the power 9. QA. So QA is a charge placed at A is 10 microcoulomb. Okay. So 10 microcoulomb, 10 to the power -6 into QC. So what is QC? Is -2 microcoulomb. So into -2 into 10 to the power -6 divided by distance between A to C. So now the distance between A to C is 5 centimeter. Now convert the centimeter into meter. So it becomes 5 into 10 to the power -2. Okay. Plus Second one, QB. So QB is a charge of 10 microcoulomb into QC. So what is QC? QC is minus 2 microcoulomb. So minus 2 into 10 to the power minus 6 divided by between B and C. Okay, just see that from A to B distance is 20. Okay, from A to C is 15. What about the distance between B to C is 15 centimeter. Okay, now convert the centimeter into meter. So 15 into 10 to the power minus 2. Okay, do you get it now? Do you end out? No doubt. Now QA is a charge placed at A is 10 microcoulomb. Okay, so 10 into 10 to the power minus 6 into QB. So what is QB? 10 microcoulomb. So 10 into 10 to the power minus 6 divided by distance between A to B. So the distance between A to B is a total distance of 20 centimeter. Now convert the centimeter into meter. So 10 to the power minus 2. Okay, how do you get it now? Do you any doubts? No doubts. Okay, fine. Okay, so now you can go for it. So 1 5 is 5. 2 5s are 10. Okay, 3 5s are 15. 2 5s are 10. Okay, so 0 0. 1 2 is 2. 5 2s are 10. Okay. Now the initial electrostatic potential energy is 9 into 10 to the power 9. Okay. Just see the first term. 2 into 2. 4. Minus 6 minus 6. Minus 12. The minus 2 goes to the numerator as plus 2. Okay. Now, in the second term, 2 2s are 4. 4 divided by 3. Okay. So, how we can solve? 4 divided by 3. So, 1 4 is 4. Remainder 1. So, we put 0. So, 10. So, 3 3s are 9. Remainder 1. 3 3s are 9. Remainder 1. Like that it goes. So, what is the symbol here? Minus. So, minus 1.3 into 10 to the power. Minus 6 minus 6. Minus 12. The minus 2 goes to the numerator as plus 2. Okay. Now, what is the symbol? Plus. So, we are having only 5. So, 5 into 10 to the power. Minus 6 minus 6. Minus 12. The minus 2 goes to the numerator as plus 2. Okay. Right. Now, 9 into 10 to the power 9. Okay. Now, minus 4 into 10 to the power. Minus 12 plus 2. Minus 10. Plus into minus. Minus 1.3 into 10 to the power. Minus 12 plus 2. Minus 10. Plus 5 into 10 to the power. Minus 12 plus 2. Minus 10. Now, in all the terms, 10 to the power minus 10 is the common. So, you can take it as a common term. 9 into 10 to the power 9 into 10 to the power minus 10. Okay. Now, we are having minus 4 minus 1.3 plus 5. Okay. Right. 9 into 10 to the power 9. 9 minus 10. Okay. Minus 4 minus 1.3. So that minus 5.3 plus 5. Okay. Now 9 into 10 to the power minus 9 minus 10 minus 1 minus 5.3 plus 5. So minus 0.3. So 9 3s are 27. 9 3s are 27. So how many decimal point? 1 decimal point. Okay. Into 10 to the power. Into 10 to the power. Minus 1. Now you can take the decimal point to 1 digit. So that 0.270. joule. Okay, so what is the symbol? Minus. So minus. So this much of energy. Okay, so initial electrostatic potential energy is minus 0.27 joule. Okay, do you get it now? Do you any doubt? No doubt. So now we go to the second part, our final electrostatic potential energy. Now the charge minus 2 microcoulomb is taken to this point up to a distance of 5 centimeter. Okay. Now, what about the distance between these two? Okay, just look at the diagram. It seems to be a right angle triangle. Okay, so hypotenuse squared, that is AD squared equal to sum of square of other two sides. So from here to here, the distance is 5 centimeter. So 5 square. From here to there, the distance is 5. So 5 square. So 5 5s are 25 plus 5 5s are 25. So to take the square, we can put the square root. So square root of 25 plus 25, then it becomes 50. Okay. So how we can change? That is 50. So 5. 1 5 is 5. 0. Next 5. 2 5s are 10. So 5 into 5 into 2. Okay. For instead of 2 5, we can take 1 5. So for root 2. So 5 root 2. So from here to here, the distance is 5 root 2 centimeter. Okay. Do you get it now? Okay, fine. Now, the distance between B to D. Okay. Now, here from here to here, the distance is 5. From here to here, the distance is 15. Okay. So, BD square, that is hypotenuse square, equal to sum of square of other two sides. This is the first side, it may be taken as 5 square. This is the second side, its the distance is taken as 15. So 5 square plus 15 square. So 5 5s are 25. 15 15s are 225. Okay, 225 plus 25, 250. So to take the square, you can put the square root. Okay, so 250. Okay, 5. 5 5s are 25. Okay, once again 5. So 1 5 is 5. Remainder to 10. So how we can write? So 5 into 5 into 10. Okay, so for instead of 2 5, we can take 1. So 5 root 10 is the distance between B to D. Okay, 5 root 10. Okay, do you get it now? Okay, so now we have to calculate the final electrostatic potential energy. Okay, so what is the potential energy between A and D? Okay, so electrostatic potential between A and D, that is 1 by 4 pi epsilon 0 QA into QD by RAD. Electrostatic potential energy between B and D. So B and D, that is equal to 1 by 4 pi epsilon 0 QB QD by RBD. Okay, now between these two. So electrostatic potential energy between A and B, that is 1 by 4 pi epsilon 0 QA QB by RAB. Okay, so when we add these three, then we can get the final electrostatic potential energy. Okay, so on the other hand, on the right hand side, 1 by 4 pi epsilon 0 is the common one. Okay, so 1 by 4 pi epsilon 0 can be taken as common. So what about the remaining? That is QA QD by RAD plus QB QD by RBD plus QA QB by RAB. Okay, do you get it now? Do you end out? No doubt. Now 1 by 4 pi epsilon 0, that is 9 into 10 to the power 9 into QA into QD. QA, that is 10 microcoulomb. So 10 into 10 to the power minus 6 into QD minus 2 into 10 to the power minus 6. So minus 2 into 10 to the power minus 6 divided by RAD. So distance between these two, the distance is 5 root 2 centimeter. So 5 root 2 into 10 to the power minus 2 plus QB. So charge at B. Once again 10. So 10 into 10 to the power minus 6 into QD. Charge at D is minus 2 microcoulomb. Minus 2 into 10 to the power minus 6 divided by RBD. Now the distance between these two, that can be taken as 5 root 10. Okay. So 5 root 10. So to convert the centimeter into meter, so it is multiplied by 10 to the power minus 2. Okay. Plus QA. So what is the value of QA? 10 microcoulomb. So 10 into 10 to the power minus 6 into QB is the, once again, the 10 into 10 to the power minus 6. 10 into 10 to the power minus 6 divided by RAB. Now the distance between A to B. A to B distance is 20 centimeter. So 20 into 10 to the power minus 2. Okay. Do you get it now? Do you have any doubt? No doubt. Okay. So now 1 5 is 5. 2 5s are 10. Okay. So 9 into 10 to the power 9. Okay. Now 2 2s are 4 minus 4. In the denominator we are having a square root of 2. In the numerator 10 to the power minus 6. Here we are having minus 6. The minus 2 goes to the numerator as plus 2. Okay. Now plus into minus. Minus 1 5 is 5. 2 5s are 10. So 2 into 2, 4. In the denominator we are having root 10 into 10 to the power minus 6 minus 6. The minus 2 goes to the numerator as plus 2. Okay. Now 0 0. 1 2 is 2. 5 2s are 10. So plus 5 into 10 to the power minus 6 minus 6. The minus 2 goes to the numerator as plus 2. Okay. Now do you have any doubts? No doubts. Okay. Now we are having 10 to the power 9. So 9 into 10 to the power 9. Okay. So minus 4 by root 2. Minus 4 by root 2 into 10 to the power. Minus 6 minus 6. Minus 12. Minus 12 plus 2. Minus 10. Okay. Now here we are having minus symbol. Okay. Now 4 by root 10. Okay. 4 by root 10. Into minus 6 minus 6 minus 12 minus 12 plus 2 minus 10. So 10 to the power minus 10. Okay. Here we are having plus 5 minus 6 minus 6 minus 12 minus 12 plus 2 minus 10. So into 10 to the power minus 10. Okay. 9 into 10 to the power 9. So in all the terms we are having 10 to the power minus 10 as a common. So minus 10 can be taken as common. So what about the remaining? Minus 4 by root 2 minus 4 by root 10 plus 5. Okay. So 9 into 10 to the power 9 minus 10 minus 1. Okay. Into. So when we change these things. Okay. Minus 4 by root 2 minus 4 by root 10 plus 5 by 1. Okay. So when we multiply and change the value, so finally we can get 0.8172 joule. This is the final electrostatic potential energy. Okay. Do you get it now? Okay, fine. So what they are asking? Calculate the change in potential energy. So what is change in potential energy? That is change in potential energy. The final potential energy minus initial potential energy. Okay. So now what is the value of final? 0.8172 minus initial. So already what we calculated? Minus 0.27. Minus minus becomes plus 0.8172 plus 0.27. Okay. So now we can add 0.8172 plus 0.27. So 2, 7. 7 plus 1, 8. So 8 plus 2, 10. So 1.0872 joule. Okay. So in our problem, how in the first part we divided 4 by 3, then we can get 1.333. Okay. So for instead of solving like that, when we are keeping 4 by 3 as it is, then our answer is 0.3. So 0.3. So when we put 0.3, then your answer is 1.12. So that is the answer which is given in your book. But how we solved it? We divide the value 4 by 3 so that we can get 1.33. So that our answer is like this. Okay. So whatever it may be. So 1.08. So when we round off that one, so that it becomes 1.1 joule. So which is also correct. Okay. So next one, interpret your result. Okay. So finally we can get the positive value of energy, that is 1.1 joule. It shows that the external energy is required to move the -2 microcoulomb charge from C to D. Okay. Or otherwise A to B. So from A to B, we have to do some external work. Why? Because it shows the positive symbol. Okay. Now do you get it now? Do you have any doubt? No doubt.